Hello. Nice to meet you all again. Have you watched the movie The Day After Tomorrow? This disaster film revolves around the issue of climate change disrupting the North Atlantic Ocean circulation, leading to a series of extreme weather events and plunging the world into a new ice age. Tokyo is attacked by a giant hailstorm. Los Angeles is devastated by tornadoes. And 3 helicopters freeze mid-air after flying into the eye of a superstorm. In New York, a tsunami surges in, submerging the city. To cater to the Hollywood factor, filmmakers exaggerated the speed at which ocean currents collapse and amplify their impacts. Scientists believe that in reality, an event of such magnitude could take hundreds of years to occur. But a study published in March of this year in the reputable scientific journal Nature focused on the ocean currents in the southern hemisphere and found that global ocean currents could collapse in less than 30 years. And although the cascading effects of this event are entirely different from what you see in The Day After Tomorrow, they are believed to have equally destructive potential. The question is, what can we do to prevent this? Let's start from the beginning. What are global ocean currents, and what has created them? Global ocean currents are a series of interconnected deep and surface water flows controlled by winds and the salinity of the ocean. In the waters near Greenland in the north and the Weddell Sea off the coast of the Antarctic continent, a large amount of seawater freezes into massive ice sheets. When seawater freezes, it leaves behind salt, making the water around these ice sheets salter than normal seawater, and consequently, denser. This denser water sinks, pulling in new surface water and creating a flow. Due to the deep seafloor topography off the coast of Greenland and the Weddell Sea, this denser, salter water is pushed into the tropics as a deep ocean current, where it collects nutrients. The wind pushes surface water away from the tropics towards the poles, and in turn, draws up deep ocean currents to the surface, creates circulating ocean currents that flow around the world. You might think that these ocean currents are just a random phenomenon of ocean dynamics. However, they play a crucial role in the global climate. They are an integral part of Earth's carbon cycle and an indispensable component of the marine ecosystem. You can imagine ocean currents like a conveyor belt. They transport warm water and rainfall from the equator towards the poles and cold water from the poles back to the tropics. On Earth, the equatorial regions receive the most sunlight radiation, while the poles receive the least. By circulating warm and cold water, ocean currents regulate the climate, making the weather less extreme. Without equatorial ocean currents, the equator would be excessively hot and polar regions would be extremely cold. Oceans also absorb carbon dioxide, converting it into carbonic acid. In fact, the oceans absorb about 25% of the carbon dioxide emitted by human activities, helping to mitigate climate change. Global ocean currents take carbonic acid and bury it beneath the ocean floor, where it transforms into carbonate and is safely sequestered for many millennia. As the deep-sea portion of the ocean current flows along the ocean floor, it absorbs nutrients such as iron, phosphate, nitrogen, and calcium. These nutrients are crucial for marine organisms, and surprisingly, they are often deficient in most sunlit layers of the sea. Nutrients determine the richness of the marine ecosystem. Therefore, in places where deep-sea currents bring up nutrients, life will grow strongly. So how the hell can these currents stop? Because of climate change. As the Earth warms, less ice is formed at the 2 poles. The seawater becomes less salty, and less sinking occurs in the waters off the coast of Greenland and the Weddell Sea. If the sinking currents in the Weddell Sea and Greenland stop, it will disrupt the conveyor belt and collapse the entire global ocean current system. If this happens, the weather will become much more severe, and marine biodiversity will also collapse. The cessation of ocean currents would disrupt the process of transporting warm water towards the poles and cold water towards the equator. This could lead to extreme temperature changes, with some regions becoming significantly colder while others become much hotter. Equatorial and near-equatorial countries, and even some near-tropical countries like India, may become excessively hot for human habitation, especially during the intense heat waves in summer. The ocean currents in the Indian Ocean influence the monsoon winds and precipitation patterns across Asia. The cessation of these ocean currents could lead to changes in the intensity and timing of monsoons, affecting the water sources and agriculture of the Indian subcontinent, home to over 1.4 billion people. Changes in the Pacific Ocean could impact the frequency and intensity of storms in coastal areas of East Asia, and countries in Southeast Asia such as the Philippines and Vietnam may experience more frequent and severe typhoons and super typhoons, causing significant damage to both human lives and infrastructure. The North Atlantic Drift, an extension of the Gulf Stream, warms Western Europe, contributing to its milder climate. If the Gulf Stream were to stop, North Korean clothing might become a new trending product in Western Europe. The Southern Ocean circulation plays a crucial role in maintaining the isolation of the Antarctic continent and regulating global climate. If this circulation were to halt, sea ice would decrease in the north, impacting the marine ecosystem in the Southern Ocean. The Pacific Ocean plays a crucial role in transporting heat across the equator. Changes in Pacific Ocean currents can disrupt phenomena such as El Niño and La Niña, leading to more severe and unpredictable weather patterns in countries around the Pacific Rim. The sudden cessation of ocean currents would disrupt the transportation of nutrients, larvae, and various marine organisms. The migration patterns of many marine species, including their reproductive and feeding habits, would be significantly affected. Numerous economically important fish species could disappear or experience a decline in yields, impacting the fishing industry and your lunch, as well as the overall marine ecosystem. Many ecosystems, especially coral reefs and coastal areas, rely on ocean currents to maintain balance. The cessation of these currents can disrupt these ecosystems, leading to the decline of certain species and the flourishing of others. The interaction between the ocean and the atmosphere will also undergo significant changes. This can affect the exchange of gases such as carbon dioxide and oxygen, influencing the composition of the atmosphere and potentially exacerbating global climate change. The cessation of global ocean currents can lead to the redistribution of water, causing sea levels to become more uniform. Some areas may experience a rise in sea levels, submerging certain regions, while other areas may see a decrease in sea levels. Although these chain effects are not like what you see in the movie The Day After Tomorrow, their impact is still extremely profound and extensive. However, the majority of scientists remain fairly confident that this is not an urgent issue. Most of their climate models suggest that ocean currents will continue to function well for many centuries to come. But it should be noted that these models are based on research conducted in the Northern Hemisphere, focusing on ocean currents in the North Atlantic. However, the study by the authors Jian Li, Matthew H. England, Andrew M.C.C. Hogg, Stephen Arentoul, and Adele K. Morrison reveals a concerning reality. While the flow of water down from the Greenland Sea in the Northern Hemisphere is expected to remain stable for over a century, the flow from the Weddell Sea in the Southern Hemisphere is highly sensitive to climate change. Specifically, models in this study predict that by 2050, the flow rate from the Weddell Sea could decrease by up to 42%. This reduction may be sufficient to disrupt the stability of ocean currents and, at the very least, significantly diminish the strength of global ocean circulation. Worse yet, this model predicts that by 2100, this downward flow will cease entirely, leading to a complete collapse of the global ocean circulation. While you might think that this is still a long way off, it's worth noting that even a slight reduction in the strength of the global ocean currents can accelerate climate change because the ocean absorbs less carbon dioxide. Extreme weather events can result in fatalities, and marine ecosystems are at risk of collapse. To prevent, or at least postpone that grim future, we need to ensure the achievement of carbon neutrality by 2050 while keeping global warming at no more than 1.5 degrees Celsius or, at most, 2 degrees Celsius. This way, there will be enough ice caps to provide the energy for the ocean currents to continue flowing. We have 27 more years to see if humanity truly wants to save their planet. Feel free to share your thoughts on the potential risk of the global ocean current system ceasing to operate in the comments section below. As always, remember to like this video if you found it interesting, subscribe to the channel, and hit the notification bell to stay updated on scientific news from Infinity News. For now, goodbye, and see you in the next video.